Alright, so you are very welcome to Protastructure Masterclass Steel Design Training. And so, in the last presentation, we were able to look at steel design, and then we explained what it is. We also moved to talk about the method of steel designs, where we talk about allowable strength design, and then we talk about the loading combination in that respect. We move ahead to talk about the load and resistance factors design method, and as well as the loading combinations based on the load and resistance factors design method. Then we proceed to talk about steel frame, where we have the first one to be frame structure, and then we are able to explain with the image example of steel frame structure. We also talk about Prota frame structure, which we talk about the image of that as well. Then we discuss about trusses. This one I just added it new because it's part of the four major type of steel frame that we have. So it is in the file I sent to you. This is a truss structure. So this is a truss structure. I hope you're there.
Yes, I'm with you. I can hear you.
Alright, so you were asking me about MTM mass. MTM mass is basically consists of a truss system. So it's basically like this image we have in here. Alright, so it falls under truss structure. And then we talk about grid structure. Alright, which is a series of space trusses that form this grid structure. After which we will also move to Protastructure, and then we learn about unit, how to change unit and carry out some basic settings in Protastructure successfully. Alright, so today we will be looking at importing grid lines from AutoCAD into Protastructure, and also referencing the grid line in AutoCAD using orthogonal axis generator to generate those grid lines in Protastructure. I could remember in the last class we were able to discuss about how to draw grid lines in Protastructure, how to offset, how to extend. Alright, we also discussed the orthogonal axis generator, which was where we stopped in the last presentations of this training. So today we'll be looking at AutoCAD. So I'll activate an AutoCAD. So we are going to be considering how to model a Prota frame structure. So we have these grid lines. Of course, we can get it dimension. Alright, so
yes,
we can pick dimensions 2 right there, linear, and then dimension on it from point to point. So this 7 meters, right? So we can go continuous right there to get that 7 meters. So we are having a Prota frame that is going to span 7 meters. Alright, and then the spacing between the individual reinforced concrete columns is going to be dimensions, and then you can see it at 5 meters. Alright, so
yes,
now majorly when you are setting out a Prota frame structure, and then in these vertical directions where your polines will be oriented, you should mind the span that you give between the column, so as not to affect your polines. You know, although poline's length is actually more than 5 meters, but if it is much, it may deflect. So it is advisable to maintain at least maximum of 5 meters and between 5 meters and 4 meters. Although if you have up to 6 meters, okay,
yes,
if you have up to 6 meters, you can choose to increase the thickness of
the thickness of the stanchion
of the polines. I'm talking about the polines now, because your polines is going to be oriented in this direction. Well, I will explain this to you as we make progress. So let's complete this dimension. Alright, so we are having a Prota frame. Then let's get the total length of this. This is about 20 meters by 14 meters. 20 meters by 40 meters Prota frame structure. Alright, so this is the grid line set out. I believe you must have understand AutoCAD to this extent.
Yes.
Of setting out the grid lines just like this, which is not difficult. So the first method we are going to be using to actually set out this grid line in Protastructure, we will be considering the orthogonal axis generator to set out these grid lines. Alright?
Okay.
So after which we will now look at importing this grid line from into Protastructure from AutoCAD. So when you are to do orthogonal axis generator to in terms of setting out these grid lines, you have to know the grid line spacing. Like in this, we have a spacing of 5 meters, 5 meters, 5 meters into how many?
4 places.
4 places. Yes, that's true. And then in this other way, we have 7 meters into 2 places. All right. So
that's the Prota.
Yeah. So now we should be looking at. Okay, which part is the this is the horizontal grid lines. All right.
Yes.
This one is the horizontal grid line, and then this is the vertical grid lines. So let's take note of that so that we can be able to produce exactly what we have here in Protastructure using orthogonal axis generator. So let's get back to Protastructure. We'll get rid of this existing grid lines we created. Select it all, right click, select delete options and OK options in the member filters dialog to get rid of this. This may not necessarily delete. The reason is because we have some stories here. So you have to get rid of the stories that we have. Okay, this is actually a structure. But then let's create a new project. Alright. So to create a new project, you navigate to the new right here, click on the new project. So to save this, we wouldn't want to save it, just say no to that and then give it a name as, you can just call it Prota frame. Prota frame structure. So for the code, we'll use zero code. Click on the OK option to create an hero code template for the design of the Prota frame structure. So the hero code template is set now. The next point is setting out the Prota frame structure grid lines. So you click on the orthogonal axis generator right there. Once you click on that, you have to pick a point in the scene environment to enable the dialog for the grid lines setting out. So click on this point or any point of your choice to have the orthogonal axis generator grid lines just like this. Okay. So what we have in AutoCAD is that just as I've explained in the last presentation, the direction 1 axis or axis level A is the horizontal. Yeah, you are there. So we have 5 meters right there in what we have in AutoCAD. Okay, we have 5 meters into 4 places. So over here you just have to have 5,000, okay, which is equivalent to 5 meters asterisk 4, because we have it into 4 places. All right.
Yes.
Then in the direction 2, which is axis level 1, we have 7 meters, which is 7,000 millimeters into 2 places. So you key in 2 right there. So this is the grid lines set out of this Prota frame plan we have in AutoCAD using the orthogonal axis generator right here. So what you need to click on the OK options to have it placed like this. You can see.
Okay.
So that is the first method. The second method is importing it from AutoCAD. So now I want to tell you the disadvantage of importing it from AutoCAD. Okay?
Yeah.
When you import a grid line from AutoCAD, you will notice that the grid line numbering will not be organized.
Yes.
So it will not take you time to renumber your grid line to make it organized before you proceed in your modeling. So that is one of the disadvantage of importing.
But for the complex structure, it's ideal we'll do that. We'll use the DXF format.
Yes, yeah, but it will not take you time to edit the whole grid lines of the complex structure to make it in order. So that is what I'm trying to explain here. Although there's another advantage whereby Protastructure have the ability to actually detect your column points and insert it accordingly as you import the grid lines alongside with the columns lines in layers. Alright. Well, let's go into the second method. I'll highlight all of this. Grid lines, delete it off, just like this. So, to import from AutoCAD, we need to get to AutoCAD first and do some important settings right there. So here in AutoCAD, what we just need to do is, you have to make sure that the grid lines are layered. So I selected this one. You check over here in the layer property provisions, you see it is grid. It is named grid, alright? Likewise, the columns lines should also be layered. If I select it, check over here, it is named column. Alright, so layers has been assigned to it. Very important, because Protastructure actually reads the layers. Okay. So the next point we need to do is we need to take this to the origin of the coordinate system of AutoCAD. The reason is because we wouldn't want to mix the grid lines after being imported into Protastructure, and we want it to start from the origin of the universal coordinate system of Protastructure as well. So what we have to do is we will look at the 0 point of the XY coordinate. So to locate the 0 point of the XY coordinate, you just have to either select line, alright, or type L on the keyboard for line, enter, type 0 right there, comma 0 right there, just like this, enter, and you can see automatically we have located the 0 point of the XY coordinate. So having located this 0 point, just click anywhere X and escape. Then highlight the grid lines as well as the column lines. Okay. Then what will move it to the origin. So M on the keyboard for move, enter, and then we trace this point down, trace this other point down, and then the traced intersection, picked it there, and take it to the origin, then place it here, just like this. Then select this line, get rid of it because it's just like a construction line or a reference line that enables us to locate the XY coordinate point. So we just get rid of that. So with this, we are good to go. Let's get rid of this text. We wouldn't need it, or we can move it away from here. All we wanted is the grid lines and the columns. So we get all of this selected. Now we need to convert this to DXF.
Okay.
So you get it selected first, after which type W on the keyboard. W is for window, enter. W is for right block rather. Okay, right block. So you enter. So in the right block dialog, you have to select your instruction unit, which we will be going by millimeters. Alright. Okay, so I will select the unit. Alright, you select the same unit you are having in Protastructure. Take note. Alright. So I will select the unit. Are you there? Hello.
I'm with you.
So having selected the instruction unit, click on these 3 dotted provisions. So this will take you to where you should save this file. Alright, so we want to save it on the desktop right there. Okay, so and then you have to give it a name. So we can just call it Prota frame right there, just like this. Then the version of AutoCAD doesn't mind. Okay, you can save it at any version. Click on save right there. The next thing you are supposed to change there is to change it to DSF. So get back to that provisions. Now the file type, file of type. Alright, selecting these provisions. So instead of DWG, select DXF. You can use any of these SF versions right there. Okay, click on this save. Alright, so after which click on OK. So that file has been saved to the desktop right there. Okay, now let's get back to Protastructure. Here we are in Protastructure. So we want to, hello
Engineer,
yeah,
what are the real life example of a Prota frame?
a Prota frame can be a workshop building,
Okay.
steel workshop. Yeah, so steel workshop can be constructed using Prota frame system. All right, it can also be constructed using truss system. It can also be constructed using a normal building frame system. So
What of warehouse?
warehouse can also be constructed. Warehouse can also be constructed using Prota frame. All right, it's a two-dimensional structure. All right.
Okay.
Okay, so we proceed. We will be importing the grid lines right now from the desktop. So you just have to get to the building setout tab right there, and then you come over to the quick start panel and select DSF import right there. So in this DSF import, you should make sure the unit of file you are bringing in is in millimeter, which you have set that in AutoCAD successfully. Apart from that, we should also be confirm that what you are importing is a floor plan. If you are importing a 3D physical model or 3D analytical model, you should also specify it here. But in this case, we are importing in floor plan. So we select floor plan. After which you can also play with the minimum beam length, right, and the maximum beam length and the rest of that. But you can leave all of this at default. So select this load DSF. And then this will take you to a directory, which is the desktop directory, or if it didn't take you to desktop, you have to navigate using this left pan to your desktop right there, and then look for the file Prota frame, this one, get it selected and click on the open right there. Alright, so over here confirm the layer's name, alright, which is grid and columns, just as we have explained in AutoCAD. After which you just have to proceed to click on the import option. So clicking on the import options, we actually import the grid lines, the columns successfully. So importation is completed. Click on the close option. Here is the grid line. So you can see we actually took the grid line system to the origin. Now in Protastructure is also at the origin. Alright?
Yes.
So we make progress, just as I've said earlier, that we import a grid line from AutoCAD into Protastructure. The grid line numbering is not always in order, so you cannot see the way it is.
Yes.
So you now have a little work to do by renumbering it. Alright, so the vertical grid line is supposed to be numbered numerically, while the horizontal is supposed to be alphabetically. So you just have to get all of this selected, right click, and then click on each property. So axis table property will pop up. In these provisions, you can now change it. A1 is supposed to be 1, right? While A2 is supposed to be 2, A3 is supposed to be 3, just like that. And then the numbering in that direction is done successfully. Click on the close option to close that. Now, in the horizontal directions, you have to zoom closely to be able to see the grid lines. Alright, get that selected. We have A4, A5, so zoom it in such a way that you can see. Right click, property, A4 supposed to be A, right?
Yes.
U capital letter, A5 supposed to be B, and AC is supposed to be C, S7 supposed to be D. Alright, so these are the one we are seeing for now. So click on the close right there to check it and confirm everything is fine. So we still have one left, which is A8. Alright, so you can always select that, right click the property A8, you have it to be E. Just like this, click on the update right there, close. So we now have this. Alright, are you there?
Yes, I'm with you.
So based on the extent we have gone, do you have any question?
No.
Okay, let's make progress. So the next thing we'll be doing is we are going to be setting story. So the things that we should have at the back of our mind is the height of the structure, or the portal frame structure,
Okay.
and as well as the foundation depth. Okay.
Okay.
So we will set that up going to the certain provisions of the stories. So we are going to be having two stories. One story is going to be for the substructure, and then the other story is going to be for the superstructure. So
okay, one for the concrete layer and one for the steel layer.
Yes.
Okay.
So we will get to the stories right there. Right click, and then you can click on insert stories, or you can also pass through bidding set out, come over to where you have stories, these provisions, click on the stories operations, and then you see the same functions right here. You can insert story also in this provision. Click on insert stories. So we need just two stories. So you click select, key in 2 right there, and then OK, yes option.
Okay.
Then you navigate back to the story 1, and then at this time around we are having these stories at default 33 meters. Okay, so you can see story 1 is 3.0 meters, and then story 2 is 6, okay, which is 3 plus 3 right there in the structural 3 provisions, these provisions right here. Okay.
Okay.
So we select the story right there and right click, and then you have to get to edit story. So in this edit story dialog, story 1, we are going to be taking it to be 600 or 450. So it all depends on the story bottom level we actually wanted.
Okay.
So these provisions, this 450, we are supposed to provide it here, but we don't want to be concerned about the Protastructure story level. So this is going to be our story level, which is story 1. Okay.
Okay.
So the 450 is just like from the surface of the earth to the floor of the structure, portal frame structure.
Okay.
This is the 450. While this 3000 is supposed to be the height, and then we make it 4500.
Okay.
Because we are considering designing maybe a workshop or a warehouse. You get? It can be used for any of those purposes. And then from the surface of the earth into the earth, we should have that as the depth of the foundations. So we can have that as 1100 for the sake of these presentations. Alright?
Okay.
We proceed. If you come over here, I see structural system. So at story 1, the structural system is supposed to be ROC, reinforced concrete. Then from at story 2, structural system is supposed to be steel. So you should select this accordingly.
Okay.
Alright, so having done that successfully, click on the OK option. Then now we are done with the settings. So if you navigate to the 3D, and then you can be able to see that you cannot have a very short pedestal. In this case, you don't call this a column, you call it pedestal because it's a very short column. Alright?
Yep.
So the total length of this pedestal now is going to be 1550. Alright?
Yes.
Do you know how we got that?
No.
Alright, so the depth of the foundation, like if I double click on the story, 0 right there. You can now see where the grid line is, alright?
Yes.
So from where the grid line is to this anchorage point is this main substructure or the length of the foundations, alright?
Okay.
Which we selected 1,100 for it.
Okay.
Or 1.1 meter. Then from the point of the grid line now up to the top of the pedestal is the 450.
Okay, I get you.
So if you sum it up, you'll now be having 1,550. Alright?
I get you.
Okay. So if for instance we should have a ground beam, then we can now navigate to the story one and be able to place a ground beam all around here. Okay, sometimes we do that, but sometimes we wouldn't do that. It depends on what the client actually wanted. But if for instance we should do that, we can just navigate to the modeling tab right there, click on the beam right there. So in the beam dialog, you can now be able to provide a beam thickness. I use 225 beam by 350. So you can easily place at the first point, take it to the last point to insert the beam, just like this. We may not go in the other directions, but we can always connect this just like this. Alright. For the sake of rigidity, we may have another beam at the center. Alright.
Okay.
So we'll first of all close this dialog and then be able to pick this property to place a reinforced concrete column right there. Alright. Then we select this beam, use its property to actually connect this and that successfully. So we do this so that at the level 1 the structure can be more firm right there. So after which we will now have to navigate to the story 2 right there. Here is the story 2. So we want to start to inserting the extension. So we navigate to the steel member provision right there, click on these columns right there, steel columns, and go to the section manager, and then it is advisable that you use UB for your beams, alright, instead of UC.
Why?
Because UB is easily found in our market.
Okay.
And again, it's less expensive.
Okay.
Or cost effective. But UC is quite very expensive in the market.
Okay.
So it is always advisable you use UB as your column or stanchion. Also you use B as your Prota frame. Okay?
Okay.
Which is the beam rafter, right?
Okay.
And another thing you need to know, steel section from 125 to 178 are called joist. Okay?
Okay.
But from 200, from 203 up is when you should be hearing of steel beam or steel column. Alright?
Okay.
So we will choose 152. We are going to try this section in this design. Alright?
Okay.
If it doesn't pass, there's a provision where we can edit and make changes to the section successfully. But at first, let us go by the smallest section. So we click on the select option. And then the orientation is very important. So we can rotate it at 90 degrees by clicking in this rotation provision. Click on the OK option. So now you have to select the grid line intersections. You can see it just like this. It's been placed successfully. So you continue to place that at this grid line provisions. Okay, so the same thing in these other provisions. Alright, then after which close this dialog. So we have this now.
Can't we place it in the plan?
You can also place it in the plan, but placing it in the plan, you must make sure you are at story 2, and then you navigate to the plan view of story 2, so you can see the beams we placed here. Okay.
Yes.
Alright, so having done that, we will proceed to place the beam rafter. So I will advise you always do that at 3D, the beam rafter, right?
Okay.
So you get back to the steam member, and then this time around beam. So you get to the sections property UB as well. You can use the same sections, alright?
Okay.
So we select also 52, 89, and 16 thickness. Click on the select options.
What about the orientation?
So we wouldn't change the orientation this time. Okay.
Okay.
Click on the OK options. Now there are more settings we need to do, but we'll do that. Let's first place the beam from this point to this point to this point. This is the apex point. Okay, but this point have to be elevated. Alright.
Okay.
So first of all, placed it is going to be horizontal, just like this at first. Then you now get to the dialog, go to where have 3D, and then you can be able to know the J and the I end. Let's say this is the I end. Then what will be the pitch or the height of this apex point of the beam rafter? So we can take that to be maybe 1500. So click on the update right there. You see it's not that direction. So you change directions, key in 0 right there and take it to these directions, and then you can now key in 1500 as the apex height of the beam rafter. So we'll have something of this kind.
Okay.
So it all depends on you. This apex height is not constant. As an engineer,
Okay.
you should know the reliable apex height. So if I want to change this now, can be able to change this to 2000 or 2 meters. Click on the update, it goes up again, just like this. That's it.
But there should be max and minimum now. Now what do you think?
If you want it to be gentle, you should know if it is tips, alright, it can carry
Yes.
it can carry the police comfortably if it is steep.
Okay.
But if it is too gentle, there's probability of failing. So you shouldn't allow it to be too gentle. Alright?
Okay.
So after which you just continue to place this. Pick the first point, pick the second point to place that. So once you placed it, to get rid of this command, you have to right click on your mouse. Then pick again.
Okay.
Get rid of the command, right click on your mouse. Go again. Right click on your mouse. So you have this. Alright? So close this dialog, and then we have to mirror this to this other side. So to have this mirror successfully, you have to select the first one. Okay? Hold the control key on the keyboard. Select the rest of the beam rafter successfully, just like this. After which you can right click on the keyboard to get the mirroring option. Or
Okay.
you can also find mirror on these provisions. Alright, there should be a mirror options right here. It's not in this version. In version 2022, you'll find the mirror options in these provisions. Okay, but you just right click and then look for mirror. This one, alright.
Yes.
Select it right there and then pick the center grid lines, which is grid line 2. After we click on it, OK. This has mirror successfully, you can see.
Yes.
So this is what we call Prota frame structure. It's a 2-dimensional structure. Alright. So
Okay.
having done this, the next thing you'll be doing is to place the Purlins. But before you place the Purlins, I'd advise that you first of all insert your braces.
Okay.
So For you to insert your braces, there are things you also need to note. As you are inserting your braces, you should take notes, ensure that it doesn't have to collide with your base plate. And so there should be some offset you'll be considering while you are placing the braces, both the vertical braces and the roof braces. So that is the next thing we'll be doing. So get back to the steel members and then click on the brace right there. So pick these two columns, the first one and the second one, then wait for it to load. We have this, alright. So having this, you have to choose the profile, which is the sections you want to use for your braces. So this is 90 by 90 at default, equal angle, alright. And then under British, the list angle sections is 90, so you can change this from British to Eurocode and then be able to look for the angle sections. Okay, now we are having minimum of 15, so we can now navigate to maybe 65. Okay, 65 by 65 and then by 5 as our angle for braces. Okay, click on the select right there and then okay. So having said that successfully, we want to do some offset from the point of anchorage upward, so it wouldn't collide with the base plate and the board that will hold down the base plate. So for you to do that offset, you have to come over to where you have property of frames. Okay, see property of frame 1. So these two frames are divided into 1 and 2. You can see it here. So in the provisions of the property of frame 1, okay, you can see over here IN offset, INY offsets, alright, and then we also have the INX offset. So in the INY offset, you can just key in 200 right there, click outside. So be able to check, you can see the offset has been made right here. Okay, so we have some offset here downward. The reason is because we'll be having a tie beam here, a tie steel beam here. Okay, so if we fail to offset this downward, this will collide. The connection of this braces we clashed with the tie beam connection. So that is more reason we need to bring this a little bit downward, so that during the connection it won't clash. So I think that is fine. And then you can come over to the J and Y offset, which is this side of it, and then you key in also 200 right there, just like this. You can see. So after which, what you just need to do, you have to apply the ends to analysis. See, apply to analysis, IN offset and JN offset. So click this provision so that you will not see this analytical line right there. Okay, so applied it here, applied it to get rid of that analytical line, meaning this is being pinned to the stanchion right there. So the same thing in the frame, the same thing applicable to the frame too. Okay, the INY offset is to be 200. Okay, and 200 in the J offset, just like this. So with this, we are done with the vertical brace. So you just have to click on the OK option to have that placed just like this. You can see. So when we have another one here, so pick these two column, the same property, click on the OK options. I believe everything is placed properly, right? Okay, so the same thing we have over here. Okay, and okay, all right.
I'm with you.
All right, so we are done with the vertical braces. So for the roof brace, we are going to be selecting the two rafter, just like this. So we have this idea.
Yes, I'm with you.
So since we have a very slender length of rafter, we need to divide the braces into two. All right.
Okay.
So dividing the braces into 2, you have to come over to brace group and the count provisions. For now is 1, you change it to 2 to divide the braces into 2, the roof braces, right? In that respect, okay? So,
Okay.
so you can see this has been divided into 2 successfully. Now we need to go in and do some settings right here. So we really want this offset we are having here. Okay.
Yes.
So in the J end of the property one, okay, J end of the property one. Where's the J end? This is the J end Y offset. We make it 0 right there. Click in these provisions, you can see. All right. So we come over to this frame 2. All right. Also J end, make it 0 right there, like this. Okay. So that is it for the count 1. All right. That is it for the count 1. Then for the count 2, you have to select these provisions. You have the count 2, and then you will navigate to the I end of frame 1 and 2. Here is the I end. Frame 1, change it to 0, and then I end of frame 2, change it to 0 as well, just like this. And then click on these provisions to get that connected. Okay,
Okay, you are making them together.
Yes, so they can be connected together using a gusset plate. Using gusset plate connections, alright? Bolted gusset plate connections can't do that, alright? Alright, so having done that, click on the OK options, just like this. You have this, alright?
Yes.
The safety is applicable to this, so you zoom closely to make sure everything is fine. So you can now see that frame 1 offset have to be adjusted, alright? So you adjust that accordingly. Select frame 1, then the I end of frame 1 have to be 200 offset right there, okay, but the J end of frame 1 have to be 0 right there, okay, like this. Okay. Yes. Now go to frame 2 and then the I end of frame 2, alright, so that has to be 0. This is frame 2, I end right here, offset have to be 0, and then the J end is already been offsetted. So this is frame 1, I end. So it is 0. Change it to 0 right there. I want this to close as this one. So let's get back to the frame 1. The frame 1. Alright, frame 1. The frame 2. Let's navigate to the frame 2 right there. This is the frame 1. Okay.
Okay, you'll be doing them one by one, panel by panel.
Yes, frame by frame.
Okay.
So that is frame 2. What I was doing is to make sure I adjust this frame, the braces frame successfully. So we are trying to adjust this frame 1 I end. So let's check that frame 1 I end. This is frame 1 I end, and then this is frame 2 I end. So this should be frame 2. The I end in the Y offset is supposed to be 0. Sorry, that is going to be 200. Okay.
Yes.
Then coming over to the frame 2, the frame 2, we will have the J end to be 0, and then the I end to be 200. Yes, this is fine now. Click on the OK options to have this brace like this. So coming over to this side. So basically these are called wing braces, alright?
Okay.
So we apply the same thing here. So you have to zoom closely to make sure that everything is fine. Okay, so this is frame 1, and then we have the frame 2 right there. So we need to adjust the frame 1. This is supposed to be 200, and then this supposed to be 0. Alright, so in these provisions, this is supposed to be 0, and then this is supposed to be 200 offset like this. Okay, so this is fine. Click on the OK option.
Okay, you're moving it so that it will not collide with the steel stanchion, right?
Yes, I'm trying to arrange it in such a way that it doesn't clash with the connections. Alright?
Okay, I'm with you.
So you apply the same thing here. So you check very well, there is a big space between these frames. So you come over to frame 2 right there. So frame 2 right there. This one, the offset here, supposed to be 0 right there.
Okay.
No, this one supposed to be 200. Okay. Then for the frame 1, supposed to have here to be 0. So get back to this other count 1. In the count 1, the J end supposed to be 0 right there. Alright, while that is the I end, the J end will now be 2. Alright, just like this.
Okay.
Then for the frame 2, we will have this I end Y offset 200, just like this to offset that. Then J end Y offset to be 0. Alright, just like this. So we still get back to frame 1, offset that, and take this to be 0. So this is fine. Now click on the OK option. So we are done with the wing braces. Alright.
Okay.
So we will stop here, and then we'll continue from here in the next presentation. So with how far we have gone, I wouldn't know if you have any question you can now ask.
The only question I will have is, I don't really have any question. I'm following you the way you are going, but I want something to practice with. That's just my own bone of contention.
Okay, but I've already sent you the training file, right?
Yes.
Okay, so this recorded video now, I will also send it across to you, so you can use it for practice.
Okay. Okay.
It's alright. So we bring the presentation of today, the training of today, to a stop as we will continue from here.
Okay. Appreciate.
So are you sure you are able to practice up to this extent?
Yes.
And then you don't have any question?
No, I don't have any issues.
Alright, so even the vertical and the horizontal braces, we are able to fix them successfully? Are you there?
Yes, I'm with you.
Okay. So now what we do is the roof lines. We will be instructing the roof lines. So we will navigate to the story modeling tab right there, and then get to the steel members, and then you have polines. Click on the polines option. So once you click on that, you will have to select the rafter, first rafter, and the last rafter. So you give it some time. It's going to come up with this polines windows. So in the polines window, you can place your pointer on the rafter image. Hold down the left mouse button to turn this way, so you can see it very much well. So after which you check the profile of the polylines. Over here you can always change the polylines profile successfully. Select these provisions. You can see presently we are having 100
Yes.
millimeter polylines, and then you can always change it between 120. It all depends. You may also come back to change this after analysis is done.
Okay.
If it fails, alright?
Okay.
So let's, for instance, we used 120 millimeters polyline section. Click on the select option and then OK option. So you can also be able to manage the spacing between the polylines. Over here we are having it to be 1 meter, so you can always change it. Let's say 900 over here, and it will be adjusted automatically right there. And we can also have a cantilever left and as well cantilever to the right. Okay, and then the gap between the continuous polylines is 0. This gap is not supposed to be 0. It is supposed to be at least 20 or 25 millimeters right there. Right, so the gap I'm talking about is this space you see in here. Right, see this space? Can you see it?
No, the dialog box is covering it.
Dialog box covering it. So this, are you seeing my cursor, like my pointer? Are you seeing it?
Yes.
If I zoom closely, do you see this gap between this polyline and this one?
Yes.
So that is the 25 I'm talking about. You can even reduce it to 10. So it's closer. You can see it now. So that is it. On the cantilever, if you want to create a kind of clouding provision, you can also have a cantilever 400 millimeters, and then that is this other way. Then the second side, 1000 millimeters or 1000 millimeter cantilever. Click to have this. So here is the cantilever, left and right talking about.
Okay.
Then we can also have an offset, which is perpendicular offset. We wouldn't need that in this case. There is the first member's offset, which is this member, the distance from this point of the rafter to where the first polyline is 200. You see last member or first member offset right there. Okay, intermediate members offset, so we wouldn't want that. We leave those provisions at default. Okay, you can also delete first member, delete last member. This is the last member, this is the first member. You can get rid of that if you have that purpose and you wouldn't want it to be there. Okay, proceed to the sag rod provisions and tabs, and then you have these information for the sag rod. The rod count is 2. Alright, 2 simply means you'll be having 2 of this rod in this each of the bay of the roof polyline. So in this bay you have 2 of the rod, 2 of the sag rod right there. In this bay we have 2. If you wouldn't want it to be 2, you can change the count to be 1. You click here, you see you now have 1. Can see?
Okay.
So you can also change it to 3. You have 3 count right there. So you want it to be more stiff and stronger in this case. So it all depends on what you want to design. So let's leave it 2 just like this, and then the diameter of the rod is 12 mm rod. Okay, this rod is 12 mm rod. You can also work with the rod diameter. So it all depends on what you want. Materials, this can be changed. Presently is 275, alright, which is very good and economical, unlike 355. This strength will be most expensive, right? But at first it's fine. You select the lowest steel strength, which is 235. But after design, the program will select the right strength for you.
Okay.
Click on the OK option, and then the next provisions is the staggered offset. Staggered offset, you can actually leave it at default. Perpendicular offset default. The profile, this profile has to do with the angle. This other angle rod, this one, it is 80 by 80 by 8 millimeters angle iron that is used there. So you can get rid of that. You can see profile angle. We uncheck there. That is the profile angle, alright? The profile angle is actually this angle iron. So if you wouldn't want it, it's very simple. Check these provisions to get rid of that. And then you'll be having use rods, use use ridge rod. So you are not having this ridge rod, all right, instead of the profile angle of angle higher, right?
Okay.
So you also have offset from the first edge. All of this leave it at default successfully. So after which you can now include in analysis to make sure this provision is checked, all right? So after which you can get to the analysis to load provisions. Here we have load, so you can actually load this now, this line, or you can decide to add your clouding before you load it right away. So if you want to load it right now, well, let's do that later. We'll come back to do the loading later. Okay.
Okay.
So click on the OK options to insert the polylines, just like this. You can see. They will make provisions to place the polylines in this other face of the roof. So we pick the 2 points. You see, it's not selected. So we need to get back to the modeling tab. Navigate to the steel members and activate the polylines again. Pick the first and the last member. We'll use the first setting that we had already. So click on the OK options to have that.
Okay.
So we have already roofed, okay, the Protastructure structure successfully. Alright, so after which we now have to add clouding on this. So for you to apply clouding on this, you need to also get to CC clouding right there. Now what's the work of clouding? Clouding is serving as a roofing sheet which helps to actually transmit loads to the polylines, from the polylines to the roof rafter and then to the stanchion itself. So you can click on the clouding right there and then pick the roof polylines, after which you will have this. Okay, so we can use the default clouding, the default clouding thickness right there, after which you can come over to load. Here you can as well now load this clouding. Okay.
Okay.
So if you want to load this clouding now, click on add load right there. So it is showing all this because of the version situations that we're using. Okay, so if I check that again, it will also show us that the reason is because we have not activated the loading combinations. All right.
Okay.
So we'll click on the OK option so we can activate the loading combination. So you can see we have a clouding placed here successfully. So we can also place clouding on this other phase by going to the steel members, clouding right there, pick the steel polylines, and then if they come up the clouding dialog, click on the OK options to apply clouding in that provisions. Okay. So after which, what you not have to do is then you activate the loading. So you come to loading right there, the load cases and combinations. Right, you can see this whole place is just vacant and blank. That is why we are having that warning, right, that came up. So what you need to do is come to loading generator, click right there. So you have the vertical load combination for the horizontal load, which is for the wing aspect of it. Actually, the structure is not that high. Okay, but if the structure is high, you can come to these provisions and activate the wing loading. Alright, so let's assume we are applying wing loading to this structure. Alright.
Okay.
So we apply the wing loading right there and then click on the OK options and make sure that create different combination for steel members design, because we are using a composite systems of structure which consists of the concrete and steel. Alright, so you must check these provisions, okay, to have the combination be separated, alright, and then calculated appropriately. Look on the OK option to generate the loading combination, just like this, alright, after which click on the OK again to have that done. Now we can now proceed to loading this clouding, right, so we can get it selected. Now we get to the modeling tab and check what you have here. That's already selected, so you have to select it again, right click, and then click on Edit Property. So in the property dialog, navigate to the loading system. Now click on Add Load. Are you there with me?
I'm with you.
Alright, click on Add Load again. So you see load is being added. We wouldn't have any warning again. You can see, alright?
Yes.
So we have L1. So this L1 now we have is for dead load. So you can see G right there. So you can see we have Q, we have X, which is we have WX, which is the wheel load in the X direction. We have WY, which is the wheel load in the Y direction. So if you have any wheel load figure that you want to actually apply to the structure, you can also provide the value right here and apply it successfully. Okay.
Okay.
But apart from that, you can use the basic wind speed in meter per second to actually apply the wind loading to the structure, which I will show you that subsequently. Alright, so we haven't gotten this. Let's take our dead load for this to be 0.15 for this case. Alright, so after having done that, you can come to this provision, select here, select this, and click on OK. So this will be applied successfully. So you can see if you zoom closely, the loading has been applied, and then it is being applied from the bottom of the steel members. You can see the load direction, right?
Yes.
So this direction is not correct. Alright, so we need to turn this direction upside down by prefixing this 0.15 with a minus right there, just like this, and then you click on the provisions to update that. So once you update that, so you can now see that the load has been now directly on the roofing sheet, which is the clouding successfully. So like this, we have added the dead load. So come to this provision, select the Q load, which is the live load, and click on add right there. So for the value right here, we can now have this to be maybe 0.2 right there. Okay, so let's prefix it with minus as well. Okay, then come to these provisions and check L2, click on OK. So this has been applied as well successfully on the roofing sheet. So having done all of this successfully, just as I said earlier, if you want to apply the wind load, you can always use this WX and WY manually, okay, just the way we applied the Q load and the G load. Click on the OK options. So we have successfully loaded this face of the roof. So it's come over to this other face of the roof. Right click and click on it property. So come over to the loading, add a dead load. So we use the same dead load value as 0.1 in this case. Let's just use that. Alright, and then prefix it with minus, then select it right here, click on OK to apply that, just like this. So you use Q load, add load, and then come over here and use Q load, and just use it as one as well. So prefix it with minus, come to these provisions, apply this, OK. So this will be applied. We have loaded the outlines, the both face of the roof lines. So click on the OK option to have that done successfully. So this structure is fully loaded. Alright, so another thing we do sometimes we applied a kind of gates. We apply gates right here. Okay. So if you want to apply a gate right here, so you can come to the steel members, and you have this as gate. So click right there. So it all depends. You want to apply it along the whole length. Pick these two provisions so you can have something of this kind. Just as I've said earlier, you can always adjust this spacing. Right. So after which you can get to the sag rod, you can get rid of this profile angle, and then over to these provisions. You can also get rid of the sag rod. Okay, make the count 1 right there, like this. Okay, and then the diameter can remain the same, or you can make changes as well to it. After which, click on the OK option. So you now have something of this kind. But most of the time they use block wall to cover this. Wall. Yes, block wall. Alright? Are you getting me?
Yes, I get you.
So if you are to use block wall here, what you're going to do is to load this beam, alright, with one load.
Yes.
Yeah, so just as I was trying to explain to you, you come over here again, pick clouding. You can be able to apply clouding here. You can see. So having applied clouding here, which means you can also be able to apply load here. This is where the wind load will now come in. Yes, wind load in the X directions. We come over here. You can now be able to select wind load in the X direction right there and add it right there. So you give it a value, depend on the value you calculated, and then you can now apply it right there. L3 applied it. So you cannot have something like this, right? But it is acting from the lower side upward. Okay, so it's supposed to act perpendicularly. Okay, that is why most of the time we don't normally use it here, or use it over where we key in the basic mean speed. Okay, but in the Protastructure higher versions, you can actually be able to incline this load to horizontal directions. Alright, so you can now change direction here as well. Okay, see the direction provision.
Yes.
You can change it to X. Once you change it to X, and then you apply that. You see now it's being applied in that opposite X direction. So you can see, right?
Yes.
So you can preface it with minus as well to change it to the other way around. Let's say the wind is coming from the outside, because in this case the wind is coming from the inside of the structure, which is not right. Okay, so you can now select that to make sure that it is being changed. Now it's coming from the outside. Okay, and the whole of the structure face is being affected by the wind. All right. So having done that, now you are good to go. Click on the OK options. So on this phase 2, you have actually loaded the structure with the wind load. Okay, so in the situations where you have wall load right there, what you need to select this beam. If it's not selecting, you have to go and deselect the clouding. So I will go to the steel member provision. This cloud is already selected. Deselect it right there. Select the beam right there. Click, and then you can come to edit wall loads, and then use the normal wall loads, which is the 3.47 kilonewton per square meters. What is the height? I think we are going about 4 meters or 4.5 meters height. Okay, so you can just key in for 5 meters right there. And what is the wall thickness? We are having the wall thickness to be 9 inches, which is 2 to 5 millimeters right there. Right, so after which, if you have a door right there, you can come to edit opening provisions. Here is the wall. You add an opening right there. Now you can adjust this. You have the width, you have the height. Door height is always 2,100, but in the case of a workshop, the door height can go more higher in terms of the as to serve the equipment that maybe bring in right there. So you can use 2,500 that. So you have that, and then you see the offset, which is the vertical directions of it. You can take it down to 0. You have something of this kind. All right. Then the door width, you can as well change it. Okay, 1,800 as a workshop door width. Just like it. Then the next thing you have to now do is to centralize this. So now centralizing this, you have to change this value in the X directions. Having known that this is about 4,000 something, so you can just choose 200 right there. See, okay, that is not much. You can use a calculator to actually take that to ensure that you have the proper centralization of the door right there. Okay, so once you are properly centralized the door, right, just click on the OK options and OK again. So you can see the door is being created right there. Alright, just like this. Okay. So now we have done with this modeling. We have also done with loading. Do you have any question so far?
No.
Okay, so this is something we've done here. You can as well apply it. Now we have here to be concrete. We can also have here to be covered with maybe aluminium. So it must have a gate. So you click in these provisions, and then steel provisions, select the gate right there. This one, and then pick this first. This one to place the gates right there. We have this 800 millimeters. Use the previous settings we had, just like this. So you can as well have this right there. Okay, so if you zoom closely, you can see this is taking the other face of the stanchion. Okay, it's taken from the other face of the stanchion. Have you seen it?
Yes.
So this is not correct. You have to click on the property and then be able to come to section alignment provision. Select there under the sections, click on the OK option. So it has come to this other face, which is now correct. Right. So we now have this right there as the steel warehouse. So we are done with all what is necessary. Now save the project, click on save. Alright, so the project is saved successfully. So we now have to go into the analysis and design of this.
Where are we going to put the connection and the light?
The connection?
Yes.
Connection comes in after analysis.
Okay.
So now we navigate to the analysis tab. Click on the video analysis. And as first, you need to set the materials. Okay? But before then, you look at the project parameters, the foundations for the soil. You can actually edit this based on the soil report. So the title, fill in the title right there. Okay? So here are the codes we're using in this design. Click on the OK option. So for the wing and story loads, you click right there. So the Protastructure comes with automatic wing calculator, which you can see right there, wing load calculator. So click right there. So you will have this wing load calculators dialog. In this dialog, the basic wing speed is provisioned in meter per second. So you have to check the basic wing speed of the construction site, and then you are able to key in the basic wing speed. And then the terrain and the surroundings, depending on the hill height and the trees that you have there. So you have to set the height if you have the details in these provisions.
Okay.
So after which you are done with that. So Protastructure will generate the wing load building category. See, it's concrete, steel. So you can choose composite for this. If you are designing tower, you can choose tower and chimney. So it all depends on the category of building you are considering. After which you can as well create a report for the wing. Click on this create report. This is going to actually create a report or the wing load calculated in these provisions. But before you create a report, you should make sure you click on the apply button. You should click on the apply button. Alright. So after which click on the OK. So all of these are being calculated based on the basic wind speed in meter per second you are feeding in that provisions, and as well as the surrounding of the construction site. So click on the OK options to have that done. The next thing you do is edit material. So for the reinforced concrete column you have in the structures, you have the grade of steel to be used. You can use C20/25, okay, which is for the mix ratios of 1:1.5:3 right there. Okay, this is a normal mix ratio. Okay, it's a normal mix ratio, it's not standard. I think standard mix ratio starts from 30, right, and then we have high strength grade. Okay, so you can choose that one and then apply it to all. Click on the OK options right there. So over to the grade, you can use 460 his strength. This is a tensor, this is HI tensor. So it all depends on the one you want to use. Apply it. Click on OK. So for the bar diameters, columns, we will use minimum 16, maximum of 25. So uncheck every other words, click on the OK options. We also have beam system in this structure. So maximum of 16 right there, and then minimum of 16 and maximum of 25 right there. Okay, click on the OK options. Right, after which you have the links. The links you can actually use 10, and then let's go by 10 and 12. So it is going to select between these two links successfully. OK options. So having set all of this, you can also come over to the foundation, and then for the foundations, so the rebars for foundations, you have 10, change it to 12, remove 13, have 16 right there. You also have 20 right there in case of necessity, and then uncheck the rest of that. Click on OK options, get back to this default material. Sometimes it resets, but this is fine. Okay, after we click on the OK. So we are done with the material settings. Next thing we have to do, we need to get to the analysis tab. So before we run analysis, you have to check the project and ensure that it is free of error. So building check, building model check starts, this check right there. So fortunately we have a building model check completed. Number of error is 0. Click on closed. This time you're not free to carry out.
I can't hear you again. No.
Are you not hearing me? Hello?
I can't hear you again.
Are you hearing me now?
Yes, yes.
Alright, so I just carry out the building model check, right?
Okay.
So you click on the building model check and then start right there. You see we have number error 0 right there, so our building is fine. Okay, click on OK options and then you carry out build analysis now. So click on build analysis. So we have this interface, so you can as well analyze and design at once. Okay, or you can do your analysis and then do your design after analysis. All right, so click on the build analysis.
Okay.
Then you give it progress of seconds to carry out analysis of the whole structure. Alright, so analysis is successful. So you can now see we have relative story draft satisfy the limit in both directions successfully. Idea?
Yes.
Click on the OK options and then you have to close this. And as well, over here we have the green check, meaning analysis is done on the structure successfully. Click on the close options as well. So you now have your structure just like this. The analytical model is just like this. Okay. So with this now we can now see the behavior of the structure with respect to the loading through the animations provisions. You can also check the moment, M3 moment. So you see the moment you have right there. Alright, so you can as well look at the shear force. You can check the behavior based on the live load. So here the behavior based on live load, the behavior based on date load, within the load cases provisions. Okay, based on the real load in the X directions, you can always check that up. So have you now see the wind load action on the structure? Right there.
Yes, I'm with you.
Alright, so wind load in the Y directions. That can also be checked right there. Okay, so you proceed to the contour. You will see the solid or the structure, solid system. You can just navigate back to the result and then be able to deactivate the animations. Stop the animations, come to the contour right there. You can generate contour for this, but we really have need for this. This contour is actually used for FE analysis, right?
Yes.
So we really have need for this in this case. You can open the solid if you want to see the solid form of this structure. You can see the solid form of the members in the structure successfully, just like this. Alright, so you can actually navigate around these provisions to check some things as are important. So after we get back to the physical model, just like this, now we will now check the members one by one from the foundations, columns, or the pedestal. So you navigate to the story one, where we have the column. You see over here is not designed, so you can select it right there, right click, and then you select active story, ROC column /word design active story. So you have this dialog. This dialog you can see right here. This is not designed, so you get to the column design bash mode options. Select right there. We select all bars. Click on calculate.
Okay.
So calculation is done. You can click on the close options to have all the columns being designed successfully. The links selected is Y10 at 300 mm center to center. You can see we are having 4 Y16 plus 2 Y16 plus 2 Y16. So on each of the columns we are having up to 8 numbers of reinforcement. Right? and the diameter of the reinforcement are Y16 successfully. Check the U ratio is also nice, 0.83. Right, maximum U ratio having here is this one. So this is carrying more of this load in the structure, this particular pedestal. Alright, so the U ratio is 0.93. So you can check them individually by getting them selected. Select the interactive design to actually see the reinforcement arrangement. So you can see 1, 2, 3, 4, 8 numbers of reinforcement Y16 successfully. Alright, so this is fine as well. Click on the OK option. So we are done with this design. So we close this dialog right away. Check the beams as well. So we can just click on this refresh. Click on this refresh. And then get back to check this. See, now it's been checked with green color to show that this has been designed successfully. So get back to the beam, right click, and then we use active story options. So we have like 3 beams right there. Okay, you have to select all with design. So click on the close option. This has also been designed successfully. Okay, we only have this beam 0.6, which have the higher U ratio. The rest of the beam is carrying lesser load. This is the one that is carrying much load. Which beam 1? Right, so which beam is beam 1? Let's check that out. So close this, is done. So should I click right here and then click on this refresh to get that refresh? Change back the beams, everything is fine. We have beam 1 right there. Okay, beam 2, beam 3. Okay, so but this is showing in the these provisions as though we have only 3 beams, because 2 of the beams are continuous beams. Alright, this one is a continuous beam, which is beam number 4. Okay, so this beam and this beam are bearing the same number, which they are the same beam. Okay, are you there?
Yes. I'm with you.
Alright, so in this case, you can also group this. So when you have a beam appearing the same beam name, you can group them to be one beam. Alright. Well, group the beam, can come to group provisions and then come to these provisions where you have automatic grouping. Click in this provision. So group beam axis vertical, group beam axis within floor. So click on that provisions and then group only on group axis. So click right there. So you can see now these 2 beams have been grouped successfully. Why this one is different? So these 2 beams are the continuous beam. Alright. So after which, click on the close options right there, and then you can proceed to check the steel members now. So for instance, we want to check the steel lines. You can zoom closely to make sure you are seeing it very well. Select the lines right there. After having it selected, you can right click and then steel member design. Click that options. So you have this. Okay. So
okay, you analyze them separately.
No. Analyzing is all. Now is design we are doing.
Okay, you design them separately.
Depending, yes, on the one I select. Now I'm designing the steel lines. So this one is not designed. So you click on design, check right there. So this will check the design and give you the section class. Okay. As well, we check the U ratio, axial compression check. So all of this check has to pass design successfully. So once they are passed design successfully, then you are good to go. As you can see, everything is fine right here. Everything is fine.
That's the line.
Yes, this is the lines. Yeah. So everything is fine with the lines. Okay, so you can see the deflection check is okay right here. Okay.
Yes.
Click on the OK options, and then if the U ratio are very much smaller, you can increase. You can reduce the sections. So you see the U ratio at 0.01. So it's smaller. You can now go ahead and then change the sections of the lines. So it will be cost effective. Alright. We'll show the moment diagram. Click in this position. So you have the moment diagram. Okay. So envelope diagram, so we can check the diagram based on the dead load, live load, right? So you can also be able to print it out in these provisions. So after we click on the OK options, and then OK. So for this stanchion, you can as well select this. You must not necessarily design all of this stanchion. In the case of a massive structure, you can get the most critical sections right there. Get the most critical sections design, and then use it for the rest of it. The rest of the sections.
How are you going to know the most critical section?
You can check it, like this one, like basically the center sections are the most critical section. Alright, like these two sections, these two now are the most critical. Basically this one. See this one, where my cursor is the most critical stanchion. While the beam rafter is the most critical beam. So it's the beam that carry much load, as well as the stanchion. Now, when I check this, you notice there are some failures. If I should navigate to the steel members design, you check here, I see check for combined forces. You are having some failures right there. Okay, at the view ratio, which is 18, far greater than 1. Okay, so there is an issue right there, a lot of loads right there. So this section have to be increased. So if this section is increased, you will use these sections to apply to every other sections in your design. Because this is a section that is
they have to be symmetrical.
Yes.
They have to be the same.
Yes. You shouldn't have a different section for the sake of constructions and ease of implementation as well. So if you check this one now, check the design, click on the design check. We are still having it failed. The combined forces, let's check this last one. We still have it failed, but this one is lesser. We have a 17. So what you just need to do is you select this one, right click, and then select a steel member design. Then you have to get to change section option. So click right there. This will take you in the UB provisions. So you can now change this section from joist maybe to the universal beam of this. So let's first check 175, 102, and 19. Select right there and click on OK. So you see this has changed to 8.87. Okay. So we increase the section again.
Yes.
Come over to this provision. Change it to 203. 102 by 23 millimeters thickness. Click on the OK option, tap OK. So change it to 4. Alright, in this case, let's get back, but this time around we'll be increasing only the we can go by this and then use this thickness, okay, and take that. This has changed to 2, so let's use the last thickness of 30 millimeters. See what we have. It's changed to 1, meaning we should increase the whole sections right here to 50, right, by that. Okay. Oh, this is getting it more smaller, and then it's not encouraging. So we use this one. I believe this will passed. Now try 37 first. Yes, this has passed. It is 0.8, which is fine. Okay. So we are now having 250 by 146 by 37 millimeters. Alright, thickness of this extension. So this has passed this sign successfully. We call the OK options. So this same sections is what we will be using, okay, throughout. So you have to change all of these sections to this one, which will require you to select the columns right there, and then you click to have this interface, and then get straight away to the sections that we selected, which is this one, and this one. That's 7, right? Select that. Okay. So you can see it passes. Okay, options. There is something here. Okay, so this is how you design.
So you have to select for all.
For all, yeah. You have to select for all. This is the design process we are talking about. So you are now changing your sections to make sure that all is very fine. So come over to these provisions. I believe you can do this, right? This is not difficult. So you just come right there and pick the right sections. We have tried several section. Is this one that has passed the design? So this is the one we are using for the design. Okay. This. Right, it's fine. So the next thing we look at is the beam rafter. Alright, if you zoom closely. Right here, we have our beam rafter. You can see right there. So this beam rafter, let's design it. Let's check the intermediate, the center beam rafter, and see what we have. Select it right there. That one, right click, and then check the design status. Click on it, check right there. So we see we are having check for combined forces. It's failing, so we need to increase the sections. So come over here, and then this time around let's try it 178, 102, 19. Okay, okay again. Okay, that is not enough, so we try this one and we select and check that again. Right, this is fine now. So for the beam rafter we have 203 by 102 by 23. So this will go. Click on the OK options, and then that will also be applicable to all of the beam rafter successfully. Get to sections, click on that provisions, just like this section, select that, click on the OK, then you have that. Alright.
Yes.
So having checked that successfully, the next thing you need to check is the roof braces. So you can select that right there. Click on still remember design check. So you have this. So check it right there to see if it has passed. Okay, this has passed design successfully. The sections has passed design. Click on the OK, and then you can see slenderness ratio. Okay, is actually failing, but that can be corrected at site. Right.
Okay.
So click on the close option. Alright, so you can use these sections to design for the rest. So let's check this upper section. Let's check this one. Everything is fine too with this.
Okay.
And close this. So you can see, let's check the gate. Basically this one that we apply wind load. Right. You right click on this, number design, check selected, so everything is fine. Over here, click on the OK options and OK. Alright, so now we are good to go. This is the same thing we'll do to all of the members to make sure all as part design. After which, now move the structure to Prota. Still for the connection design successfully. Alright, so in the next presentations, we will be talking about connection design using Protastructure. So with the extent that we have gone, I want to know if you have any question.
I'm not having any question.
Okay, so
Can we do the connection today?
now our time is fast spent.
Okay.
Yeah. So
connection is the last thing, right?
Yes, connections and then drawings of the steel members. Yeah.
No problem.
Alright. So in the absence of no question, we stop here to be continued in the next presentations. Have a nice day.
Thank you. Please do also let me send the video.
Alright.
So that I can practice.
Very important. Yeah.
Take care.
Alright.